All right, I want to provide you with some help on this review sheet for the coming test. And these first few problems, this first six problems, come from lesson 4.1. So you need to know your exponent rules really well in these problems. So let's just jump right into number one. I would always approach problems like number one with the thought of simplifying inside the parentheses as much as you can first. So I'm going to start with the coefficients 8 over 24, and 8 goes into both numbers, so we can reduce by dividing by 8. So I'll put 1/3 to show the reducing of 8 over 24. When I do the two x's, remember when you're dividing, these two x's can be combined together as 1x, and we would raise it to the power of 2 minus 6. So that would be -4. And then y to the 7 minus 2 power, and that would be y to the 5th. And everything now inside the parentheses, but we've simplified it. We don't have quite as much to deal with because we combine the two x's by subtracting their exponents. Same thing with the y, but everything inside the parentheses is now going to be raised to the third power. Okay, so 1 to the third is still 1. X to the -4 raised to the third is x to the -12. Y would be to the +15. And then down here in the denominator, 3 would be raised to the third, and that's 27. Now everything looks good except for this negative exponent. You don't want to ever leave a negative exponent in your answer. So to fix x to the -12, we just move it down from the top down to the bottom. And when we move it down to the denominator, it becomes x to the +12 to join the 27 that's already there. And y to the 15th, since it doesn't have a negative exponent, it doesn't need to be changed. So that ends up being my final answer for number one. I'm going to apply the same kind of strategy here for number two. So the coefficient 6 over 1, that obviously can't be reduced. There's a coefficient 1 here that we don't see. So let's put the two a's together. So that would be a to the 5 minus 1 power. That's a to the 4th. And b would be to the 4 minus -2 power. So remember, when you subtract -2, that's really addition. So 4 minus -2 makes b to the 6th. And if you want to, you can go ahead and put a 1 there because of that coefficient 1. Everything is being raised to the -2. So here's an option if you prefer. You could, because negative exponents tell you to flip the base. The base in this case is this fraction in the parentheses. So a negative exponent would say flip the base. And then once you flip the base, you can now change the exponent to positive. So now everything inside the parentheses is being raised to the second power. So 1 to the second power, still 1. 1 times 1. 6, remember, these are all multiplied together, so each one of these separately gets raised to the second power. So 6 squared is 36. When you raise a power like 4 to another power like 2, this is when you multiply. That's a to the 8th. And then here's that rule again, a power being raised to a power, that makes b to the 12th. And there's your answer for number 2. For number 3, be careful, before you do multiplication, you have to do exponents. All right, so we have to raise a times b to the -3rd power before we multiply times anything else in this problem. So I'm just going to write this down. And then this is the product to a power rule. So each part of the product, each factor, gets raised to the power separately. So a is going to be raised to the negative third, and then b is also going to be raised to the negative third. Okay, so let's take care of coefficients first. So we have 4, and then we have a 1 coefficient, another 1, so it's like 4 times 1 times 1, which is 4. We're now multiplying, and so when you multiply like bases, like these two a's, this is when you add exponents. So this is going to be a to the negative 2 plus negative 3 power, and that's negative 5. And then the same thing for the b's. We multiply these two b's by adding their exponents. So 7 plus negative 3 is positive 4. And then the only thing that needs to be fixed to get to our final answer is, again, we can't leave a negative exponent in our answer. So 4b to the 4th over a to the 5th becomes the final answer. All right, moving on to number 4. We're going to do the distributive property with 5xy. So 5 times 2 is 10, x times x is x squared, and then y times 1, if you want to think of it that way. And then 5xy times negative y is negative 5xy squared. Now we're going to distribute the 6y squared. So when you have two variables that appear in the same term, just put the variables alphabetically. X comes before y. And then 6y squared times 6 is 36y squared. And now we look for like terms. So look for x squared y's that we can put together with this 10. I don't see any xy squares. Nope. So it doesn't look like we have any like terms. So what that ends up being our final answer, distributing really both times. So that's just a review of that rule of multiplication of like bases. How do you handle the exponents? And it's a review of the distributive property. Number 5, you're multiplying two binomials together, so this is going to be the FOIL method. So first, n times n makes n squared. The outside, n times 7, is 7n. The inside, negative 9 times n, is negative 9n. And then the last, negative 9 times 7, is negative 63. You combine the like terms in the middle, these two like terms, so 7 minus 9 is negative 2n, and then minus 63. And there's the answer for number 5. Number 6, we're going to be subtracting polynomials. So I would encourage you to distribute negative 1 to this second polynomial. So negative 1 times 3x squared, negative 1 times x, negative 1 times negative 1, and then combine like terms. So we have a couple of x squared terms. 1 minus 3 is negative 2x squared. We have a couple of x terms. Negative 5 minus 1 is negative 6x. And then we have constants. 2 plus 1 is 3. And there's our answer for number 6. All right, you're going to need to know Pascal's triangle, how it's made and how it's used on this next test. So here's the, we're told to make the triangle through the necessary row. So since this is raised to the 5th power, I'm going to stop when I get to the row that contains 6 numbers. Remember, your answer should contain one term more than whatever the exponent in the problem is. So the first row is 1. Some of you are leaving out this second row. Don't forget, there should be one number, which is the number 1. Then you should have 2 numbers, both 1s. And then the pattern starts. You just add the 2 numbers above. Each row starts and ends with 1. and then you just add the two numbers above to get this number below in the gap. So 1 plus 2 is 3, 2 plus 1 is 3, end the row with 1. The next row would be 1, 1 plus 3 is 4, 3 plus 3 is 6, 4, 1. And it looks like we need to go one more row to get to the row with 6 numbers. 1, 5, 10, 10, 5, 1. So this is the row that we're going to use to do this expansion. And here's what the expansion looks like. So the process goes like this. It's going to be repeated 6 times to get all 6 terms. So to get the first term, we start with 1 from the row. We multiply times inside the parentheses, the n, that's the first term in the parentheses. That's going to start off being raised to the 5th power, whatever this outside power is. That's going to be multiplied times -6, starting off being raised to the 0 power. So multiplying all these together is going to give us the first term. All right. Now to get the second term, we're going to multiply 5 times n to the 4th. This first term is going to go down by 1 as we work our way through. And then the second term is going to go up by 1 each time. So in just a minute, I'll multiply all that together, and that'll be the second term. Third term, I'll take the next number from the triangle, multiply times n, now dropping it down to the third, multiply that times -6, and that'll be raised to the second. All right, the fourth term, I'm going to multiply 10 times n being, okay, we're now to the second. The n is dropping by 1 each time. And the -6 is going to go up to the third. All right, next term, I take the 5, that's the next number. I multiply by n to the first, and -6 is going to be raised to the 4th. And then the last term, I go with the last number in the row, 1, multiplied times n to the 0, and then that's multiplied times -6 to the 5th. All right, and now I'll finish labeling. So this is how we'll get the third term. This will be the 4th, this will be the 5th, and this will be the 6th. Notice that to get each term we multiply, but the terms themselves will be either added or subtracted. All right, so this first set of factors multiplied together, because -6 is really to the 0 is 1. So we're multiplying 1 times n to the 5th times 1. I'll do the answer in a different color. So this is going to be n to the 5th. All right, term number 2, -6 to the first is -6 times 5. So -6 times 5 is -30. So that term 2 will have a minus in front of it. So that's going to be -30 n to the 4th. When we get to term 3, remember you do exponents before you multiply by 10. So -6 squared is 36. And now we can multiply 36 times 10. That's going to be positive 360 n to the 3rd. All right, when we get to term 4, we're going to raise -6 to the 3rd power, and that's -216. Multiplied by 10 makes -2160. And then we still have the n to the 2nd. All right, when we get to term 5, we raise -6. So in your calculator, you need to put -6 in parentheses before you raise it to the 4th power. So that's 1,296. And now multiply that by 5. And we get 6,480 positive. 6,480 n. And then finally, 1 into the 0 is 1, and we're going to do -6 raised to the 5th. And that's -7776. So for subtraction, in your binomial, the signs of your answers should always follow this pattern. After the first term, you'll have minus always, and then the signs should alternate back and forth. So you can kind of check yourself out. Now it's just for when there's minus. Now your test may have plus, and in that case, all the signs are plus. But if you have minus in your test, then make sure that your signs follow this pattern. You start always after the first term. Your first term will be positive. After that, you should have a minus, and then it should alternate back and forth. So the blue is the answer for number 7. All right. Now we get to some division. We'll do some long division first, and then we'll look at synthetic division. So number 8 is long division. I'm dividing x minus 5 into 3x cubed minus 16x squared plus 9x minus 24. So the first division I'm going to do is, I'm just going to underline it for you. I'm going to divide 3x to the third by x. So let's go over here and just see what that is. 3x to the third divided by x is 3x squared. And now 3x squared is going to distribute. It's going to multiply times both of these. I'll erase my little blue line. All right, so 3x squared times x, and 3x squared times negative 5. And with long division, you're always subtracting. So the x cubed terms are going to cancel out. That makes 0. So negative 16 minus negative 15. You got to be careful. You're subtracting a negative number. That's really addition. So that's going to be negative 1x squared. Now bring down the next term. But your actual division is just going to be this first term x into this first term negative x squared. So if you have to kind of separate that out, just off to the side somewhere, take a look at that. Negative x squared over x would be negative x. And now multiply the negative x times both of these. So negative 1x times negative 5 makes positive 5x. Subtract. The x squares cancel. And this is 9 minus 5. The 5 here on the inside of the parentheses is positive, but we're subtracting. So 9 minus 5 is 4x. Bring down the next term. And we got one more division to do. X into 4x. That's positive 4. Now distribute the 4. 4x minus 20. 4 times negative 5. Subtract. So negative 24 minus negative 20, that's really addition. So negative 24 plus 20 is negative 4. And some of you, I noticed on our quiz, you're not putting a sign here in between the polynomial answer and the remainder. So since this is negative 4, that means this is going to be minus here. And since that takes care of the negative, my remainder is shown as 4 over x minus 5. And there's your answer for number 8. All right, let's do another one. So x squared minus 5x plus 4. And I'm dividing into this, x to the 4th minus 4x cubed minus 7x squared plus 34x minus 24. You should check and make sure you're not skipping. Be careful that you don't skip, like go from 4 to 2 with your exponents. But these are consecutive, 4, 3, 2, 1, and then constant. So we're good to go. So this first division is actually going to be x to the 4th being divided by x to the 2nd. And you subtract exponents, and that gives you x to the 2nd. Now multiply. So x squared times x squared, x squared times negative 5x, x squared times 4. Subtract. The x to the fourths cancel. -4 plus 5 is 1, x to the third. -7 minus 4 is -11, x squared. And since I got 3 terms here, I'll just go ahead and bring down the third term. But the actual division is still just first term here into first term here. So let's see, x to the third divided by x to the second, that's x to the first. Now multiply, so that's x to the third minus 5x squared, multiplied by 5 times negative 5x, and now x times 4, and subtract. X cubes cancel, -11 plus, subtracting -11 plus 5 is -6x squared. 34 minus 4 is 30x. Bring down the last term, and we got division one more time. So this time x squared into -6x squared, and that's -6. And now distribute the -6 to all three of these terms. So -6x squared plus 30x, -6 times -5x. And then -6 times 4 is -24. So in this one, we ended up with a 0 remainder. So this ends up being the final answer. So there's 2 long division examples. Now let's do some synthetic division. You should always pay close attention to the number that you would plug in for x to make this become 0. And that number, that's very important that you choose that number wisely, because that number is going to go in the half box, and if you put the wrong number here, then your answer is going to be off. So it's the number that causes this binomial to be 0 if you replaced x. And now to the right of -3, I'm going to list the coefficients and the constant of the polynomial that I'm dividing into. So you start by bringing this first number down, and then numbers that appear below the line will multiply times this special number in the house. So 2 times -3 is -6. And with synthetic division, you got to switch. Now you're going to be adding. So 3 plus -6 is -3. Multiply again. -3 times -3 is 9. -4 plus 9 is 5. And now multiply again. 5 times -3 is -15. So this last column is the remainder column. So remember, with synthetic division, your answer will be 1 power, or it's really the word degree, 1 degree less than what you divided into. So since I divided into 2x to the third being the highest exponent, this is going to be the coefficient for 2x squared. And then you just count the exponents down by 1 as you move to the right. So this has to be the coefficient of x, -3. And then that means, since that's the last x, 5 has to be the constant. And there is no remainder. Last column is the remainder column. So there's the answer for number 10. Number 11, this time we're going to put 3, +3 in the house. And so we have 3, -5, -23, +24. Didn't skip any. 3, 2, 1 constant, so we're good. Bring down that first number and then begin. 3 times 3 is 9. -5 plus 9 is 4. 4 times 3 is 12. -23 plus 12 is -11. -11 times 3 is -33. And when you add these together, you get -9. So again, we divided into x cubed, so this is the coefficient of x squared. So then this has to be in front of x to the first, which means -11 is a constant. And our remainder, since it's -9, we're going to have -9 over x minus 3. And there's your answer for number 11. Now we're into chapter 5, and this is where we did operations with functions. And if there are restrictions on the domain, we need to state what they are. So this just says take the f function, which is 3x plus 2, and add to it the g function, which is x squared minus 2x plus 1. And I'm going to put this in standard form, which means my first term should be the highest exponent for x. Then my next term should be the next lowest, which would be x to the first. And I've got two of those terms. 3x minus 2x is positive 1x. And then constants, if we have them, will be last. So 2 plus 1, I can combine those. And there's the answer to the sum of f and g. And there are no restrictions on the domain. If your answer is not a fraction, then you don't have to worry about any restrictions. All right, here's the subtraction of f and g. And this is the one you really have to be careful about, because subtraction really means we're going to distribute a negative 1 to this second, this trinomial. So distribute negative 1 to drop the parentheses. And then combine like terms. So start with your highest exponent, that's negative x squared. Then combine your x's, 3x plus 2x is 5x. Then combine the constants, 2 minus 1 is 1. And again, we don't have a fraction, so we don't have to worry about any restrictions on the domain. This is multiplication, so I'm going to take the f function and multiply times the g. And this is the distributive property, but we're going to be distributing both the 3x and the 2. So we'll do separate. Okay, we'll just color code those so you can kind of follow. So the 3x being distributed would look like this. 3x times x squared is 3x cubed. 3x times negative 2x is negative 6x squared. 3x times 1 is 3x. Now, let's distribute the 2. 2 times x squared, positive 2x squared. 2 times negative 2x is negative 4x. And 2 times 1 is 2. And now it's just a matter of putting the like terms together. There aren't any other x to the third terms, but there are a couple of x squared terms. Negative 6 plus 2 is negative 4x squared. There's a couple of x to the first terms. 3x minus 4x is negative 1x. And there's only one constant, and that's plus 2. And again, no fractions, so no restriction on the domain. Number 15, however, is going to be different. So we have the f function being divided by the g. And that's going to be the answer to the f divided by g part, since there is nothing, we can't, we could factor the denominator, and that would be the only possible way to cancel if we have matching factors. So I'll just go ahead and show the factoring of the denominator. But as it turns out, even though I did factor the denominator, I don't have any matching factors that I can cancel with the numerator. But it does help when it comes to finding restrictions in the domain if you do the factoring, because basically we're going to be solving letting this quadratic equal 0, and there's only one number really, since this is the same factor. There's no need to let each of these equal 0. You just let your factor. This is just solving by factoring, just like you did on your last test. So the restriction is that x cannot be 1, and so here's our notation. The domain is all the x's such that x can't be 1. So it's really a two-part answer. This would be answer part 1. Either of these would be okay, since you can't cancel. And then answer part 2 is this is the restriction. All right, let's take a look at number 16. You might want to think about this in this way. It might make it easier. So what I've written in red is the same as the way it's going to be presented on the test. So what this means is do the 3 last. Just go ahead and do f of 2. Okay, we've done a lot of work with inputs. So I'm going to let x be 2. There's already a negative there. So f of 2 is -1. Now what this means is multiply 3 by whatever you get for f of 2. Alright, so I've just done the 3 times f of 2, and I got -3. Okay, now let's work on the g of 2. G of 2. So that means I'm going to go over here to the g function and put 2 in for x. And that's 8 plus 2 is 10. Okay, so the overall problem says once we found these two, 3 times f of 2 is -3, g of 2 is 10. Now we subtract those two numbers. Okay, so my final answer is going to be taking this 3 times f of 2, the -3, and subtracting from it the g of 2, which is 10. And so my final answer is -13. All right, so basically find each of these results. This was -3. This was -10. And then you subtract them. All right, this one's similar, except it's going to be division. And here's another way of looking at it, if that makes it simpler. So let's find f of 3, and then whatever that output is, we're going to multiply by 2. All right, so here's f of 3. F function, replace x with 3. Okay, so f of 3 is -2. So don't forget, you have to multiply 2 times that, and you get -4. So I'll just put it up here. 2 times f of 3 is -4. All right, now let's do the g of 3. And g of 3 is 4 times 3 is 12, plus 2, and that's 14. Okay, and that's pretty much it, except we are able to reduce. We can divide by 2. And so the final answer there is going to be -2/7. Now this one is h of -2 minus 4 f of -2. It's not, yeah, it's 4 times f of -2. All right, so let's find h of -2. -2 in for x, square it, subtract 1. All right, so h of -2 is 3. Now let's find f of -2. So putting -2 in place of x, adding 1. The opposite of -2 is +2, plus 1 is 3. All right, so don't forget, once you found f of -2, you still have to multiply it by 4. All right, so that's 12. So the h of -2 part, we got 3. The 4 times f of -2 part, we got 12. And now you're going to subtract those. and that should be negative. Okay, and then the next three problems involve composite functions. And so the way this is written, you would want to do the function closest to the number first. So let's do g of 2. So we're going to put 2 in place of x, and then see what comes out. So 2 squared is 4. Remember, powers first. And then negative 3 times 4 is negative 12. Now negative 12 is going to be the input into the f function. So replace x with negative 12 in this f function. So negative 24, 2 times negative 12, plus 3, and that gives you negative 21. And that's the answer for number 19. On number 20, we're going to do f of negative 5. So input negative 5, negative 10 plus 3 is negative 7. Now, negative 7 is going into the g function as an input. Okay, so negative 7 squared is 49. So don't forget to do powers before you multiply, just following PEMDAS. And negative 3 times 49 is negative 147. All right, and then finally number 21, we do f of 6. Place x with 6 in the f function, and that's 15. And now we're going to do h of 15. Well, h is a constant function, so it really doesn't matter what goes in as the input, the output is always going to be the same. So the answer for number 21 is 2. All right, this is a review of, well, this is what we did in 5.3. So we got to find the inverse of the function. That'll be answer part 1. So we switch places with x and y variables. So just treat f of x as though it were y. It's the same. And now solve for y. Get y by itself on the right side of this equation. So I'm going to add 6. And then so I can see it in slope-intercept form, I'm going to multiply by 1/5. It's the inverse of 5. And when I get down to this y by itself form, I want to use the notation that says the inverse of f. So 1/5 times x, and then 1/5 times 6. So there's answer part 1, where it says find the inverse of the function. Now we'll do parts 2 and 3, graph the function. So let's graph y equals 5x minus 6. So we start at negative 6, and then a slope of positive 5. Up 5, right 1. One more time, and then we'll connect those dots and label this as f of x. Now to get the inverse, you can either graph this guy that you came up with, or you could take these 3 red dots and just switch the ordered pairs, the xy coordinates. So I'll just show you what that looks like. This is 0, negative 6. So for the inverse, you would do negative 6, 0. This red dot right here is 1, negative 1. So in the blue, I would do negative 1, 1. You just switch them. This is 2, 1, 2, 3, 4. So in blue, I'm going to do 1, 2, 3, 4, 1, 2. You just switch the XY coordinates. And that's always a good way to get the graph of the inverse. Just take points off the original and switch the coordinates. All right, so that's the complete answer for 22. 23 is the quadratic parent. So remember what the parent looks like in its base form. We're going to shift the parent 2 to the left and 3 up, and all the points on the parent do that same thing. So the parent had the point 2, 4. So when I go 2 left and 3 up, it's there. And I can match up my symmetry line goes through the vertex. And so that becomes the graph of f of x. Let's get the inverse function. So again, switch places. I'll just come down here and do it. Switch places with x and y. So it'll look like this. And now get y by itself. So you'll have to subtract 3 first. Do the square root on both sides to get rid of the power 2. Just don't forget to do plus minus. So here's what your equation looks like after doing the square root of both sides. And now to get y by itself, we just need to subtract 2. I'm going to put that out in front so there's no question. It's not looking like it's under the radical. And now that I've got y by itself, I'm going to use the notation that says the inverse of f. And there's the inverse function. And then to get the graph, again, just like we did over here, just take points off the red. That point right there is negative 2, 3. So on the inverse, I'll just switch those and make 3, negative 2. So just want you to look at that first one. Negative 2, 3 is that vertex. And so this becomes 3, negative 2. You just switch places. Don't change any signs. Just literally pick up the coordinates and switch them. All right, this red dot, we'll just go right here. This is negative 3, 4 right here. So we'll do 4, negative 3. This is negative 1, 4. So we'll do 4, negative 1. This y-intercept is 1, 2, 3, 4, 5, 6, 7, 0, 7. So we'll do 7, 0. And then this one matches it. And this is labeled as the inverse. So make sure you label on your test, just like I've done here. And there's all your answer. Review of what we did on the last test. So here's the square root parent. Starts here at 0, 0. So this is the parent. Input 1, output 1. Input 4, output 2. Input 9, output 3. So that's the square root parent, but this is saying to shift, or the word is translate, the parent 2 to the left and 3 down. So 2 left, 3 down, every one of the points. 2 left, 3 down, 2 left, 3 down, 2 left, 3 down. And the blue, when I connect them, that represents the graph. So this is graphing by translating the parent. Okay, this is the cube root parent. So remember how we get that. Still goes through the origin. Input 1, output 1. Input 8, output 2. The cube root of 8 is 2. Input -1, output -1. Input -8, output -2. So this represents the parent, cube root of x. So what we're asked to do is translate the parent 4 to the right. So every one of these red dots is going 4 right and 1 up. All right, I just did this one. Now let's go here. 1, 2, 3, 4, up 1. Here in the middle at the origin, 1, 2, 3, 4, up 1. This one, 1, 2, 3, 4, up 1. This is going to go off, so you just kind of guesstimate 1, 2, 3, 4, up 1. And now we connect the blue. Hard to do with this board. You get it, and with your pencil, you should you shouldn't have any trouble. All right, so those are the answers for 24 and 25, and then we got 2 more. Solving radical equations. You need to isolate the radical first. Important first step. So that means I'm going to get this radical all by itself on the left before I do anything else. So that means I'm going to have to subtract 4. And to undo the square root of I square, just raise that to the second. But if I raise the left to the second, I also have to raise the right. Well, raising the square root of to the second power just gets rid of the radical. So it turns this into a pretty easy equation. I'll add 1 to both sides and then divide by 3. Here's my answer for number 26. A fraction exponent like this, just going to circle. This is the same thing as radical form, the cube root of 3x minus 1. So when you're asked to isolate the radical, it's talking about what I've circled here. So 2 steps, add 6, divide by 3. And now, just like we undo the square root of by squaring, you undo the cube root of by cubing, raised to the 3rd power. And that's going to get rid of those 2 powers. They make 1 when they're multiplied together. So 3x minus 1 is 8, 2 to the 3rd power. Add 1 and divide by 3. And there's our answer for 27. All right, that's it. And these problems will help you if you understand how these problems work. And you do them well, you should be well prepared for this test coming up. If you have any questions about it, please let me know. I'll see you next time.